This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Giovanni Asproni, and today we'll be discussing trunk-based development with Paul Hammant. Paul is a DevOps and continuous delivery expert, architect and coder, and has been coaching software development organizations on trunk-based development as a recommended way of working for over 20 years. He maintains trunkbaseddevelopment.com and has a book on the same topic. You can find the links to the site and also to the book in the link section of this podcast. These days, Paul does spot consulting remotely for teams wishing to get from where they are to trunk-based development. Paul, welcome to Software Engineering Radio. And is there anything I missed that you'd like to add?
No, I think you nailed it all. And thank you for having me.
You're welcome. Well, let's start then. What is trunk-based development?
Good question. It is a branching model that we would use with version control for team software development.
Okay, then maybe I should ask, what is version control? Can you expand on it a little bit?
Version control is a tool we would use to maintain and manage our source files, typically text, over time towards completion of a project, a ship, to customers.
So we are talking about tools like Git or Subversion, Perforce. These kind of tools are for version control. Am I correct?
Yeah, for sure. Git mostly today, Perforce in some places, games companies. Subversion still used, but most of the intelligentsia wants to use Git these days.
I can ask you another question about version control before digging deeper into trunk-based development. So we know that there were different models, like Git is a decentralized model of version control, but in the past used to be more centralized, like Subversion or before Subversion, CVS. So can you tell us a bit more about these two models?
Okay, Subversion, Perforce, and a few others. You would mostly require a connection to be the whole time to the server that was maintaining the canonical copy for the entire team. Now, you could maybe take a flight and keep working on your stuff whilst you're offline, but it got harder and harder as time goes on to not reconnect with that server for history and things like that. Decentralized Git, Mercurial in this age, allow you to originate everything offline and work for long periods of time without synchronizing with mothership, the canonical copy. But in enterprises, at least, they still have that. The version up on GitHub that the entire team is pushing and pulling from would be considered canonical. But we have the ability to maintain a longer disconnection from that canonical server.
Basically, with the decentralized model, people could work also disconnected and save the history of what their own work locally and then push it to the central repository once connected again.
Exactly that. And actually, they can rewrite their history before they push that back up to simplify what to them was 30 commits into one.
What is trunk-based development in this context?
It's a branching model, and you had many choices over the years. But in my opinion, it's the best branching model. It started its life in the 90s, evolved through the noughties into the current time frame, and it remains a persistent, high-throughput branching model. Sadly, we have to keep reteaching to the industry.
We know that nowadays use a different branching model like Git flow or some form of feature branches and things like this. So what kind of problems trunk-based development solve that those other models don't?
I met a guy some years ago, Frank Compagna, I'm not sure if I've got his name right, and he gave us a quote, "Branches create distance between developers, and we don't want that." I was quite jealous. It's a very good quote, and I use it a lot now. Multiple branches for development, the longer we keep those branches alive, the more integration pain we encounter later. So integration is the correct terminology for when we bring a whole batch of changes back into the principal canonical place. And that's merge, really, if we talk about the actual language of the source control systems. So the longer we leave it, a week, a month, a year, the worse it gets in that merge. The more we have to coordinate with other people who would be waiting for that or who've been actually working elsewhere and they were divergent over the same time span. The longer we wait, the worse that merge gets, the more confusing and error-prone it could be. So trunk-based is about trying to minimize that amount of time down to the smallest amount of time. So we could say a day.
So you just talk about one of the advantages of trunk-based development, that is about merges. So avoid situations where code changes make the code diverge in different branches for a long time, making the merge of these changes really difficult at some point in the future. But there are also some other touted advantages of trunk-based development. So some people say that feedback and release cycles are faster with trunk-based development. Can you expand on this?
Yeah, so feedback, obviously, if we're merging work back a day after origination and say that was me, and then you decided you thought that I wasn't doing the best piece of work, you could comment far more quickly one day after origination rather than 1 month or 1 year. So we could debate and I could make a follow-up commit that would make it better still, that maybe was what you were thinking I should have done in the first place. But there's also benefits that come later, like in the release cycle. If we were releasing more often as a consequence of doing trunk-based development, we have, again, a secondary faster feedback cycle, this time from the community of people who would be using the application in production or in a deployed environment that wasn't production. So that's the secondary benefit, I think. Feedback on not just the code, but actually on the product that's been built from the code.
Other advantages that you see in trunk-based development that we haven't mentioned so far?
Merge difficulty, I think we hinted at in the last couple of minutes, but also merge mistake is a thing that's generally speaking eliminated through trunk-based development. We're bringing back smaller pieces of work more often. There's a decent chance that we won't make an error during that merge back. The divergence will be smaller, so the actual merge tools of Git and alike will be far smarter. But secondarily, anything that was requiring arbitration of a human is actually smaller in number. And if a human's error-prone, it's after hours of work attempting one thing, like a merge that's taking hours. And if they're doing something that is actually error-resistant, it's a short and small piece of work that was easy to achieve. So many smaller commits, many smaller integrations that come back are less error-prone than a behemoth merge that might take more than one person to finish in more than 1 day.
Are there any risks associated with trunk-based development?
There's a few, maybe. An adept team perhaps is going to think there's no risks, but a team transitioning to trunk-based development and is remembering habits from their past might fall into some traps. An obvious one is we need to rely on automation, and if we classically came from a place of no test automation or little test automation, then we don't get to rely on that in a trunk-based development setup. So, pitfalls are we need more machines, more bots, more CI to actually look at what we're doing and to give a thumbs up. A second one, related, still a thumbs up, is that we need perhaps more eyes on code. We have less time to certify that it's correct. So we perhaps want to move upstream the moment where a second pair of eyes has a look at a piece of code. So a team might make mistakes in not doing that, trying to do code review once a month or quarterly, when they really should be doing it every single commit and within minutes or at least an hour of origination. These are the types of mistake that a team might make.
Actually, have you got an experience that you can share with trunk-based development, to describe how you used it and how it benefited your organization?
Yeah, I have a few, but I will pick an airline to talk about from my past. I wasn't the principal technician in this airline. I was one of many thought workers amongst one of many developers and consultants. And we had a setup where we were doing a medium or major release every 6 weeks. However, every single team was taking longer than 6 weeks to make their thing from start to finish. So that we'll call concurrent development of consecutive releases. What we inherited was a series of branches that the first release team would work in one branch, and on a weekly basis, you would merge their stuff into the intended next releases branch. And my team was maybe 4 branches further down than that. So that was like a cascade branching model, and it wasn't working, and we were breaking subversion, and we couldn't get support for helping us push through that break and subversion. So we proposed that we should move everyone to trunk-based development and a reliance on toggles and flags. And almost within a couple of days of effecting that, we were liberated from the merge hell. We were able to dial up our throughput, all teams. We had a new need to rely on toggles. Maybe we'll come back to that later. But we had this super productive period of time facilitated by trunk-based development when an attempt at another branching model organized around teams and intended release order was not working.
In this example, using trunk-based development was what saved the project, in a sense.
We possibly could have soldiered on with the old way, but we would have had to have slowed down our releases, made a greater interval between releases, because the dev teams literally couldn't keep up with the upstream changes that other teams had managed to lock in, because the mergings were harder and harder to do. So it did save the throughput, but maybe if you wanted to be cynical, we could have stuck with the old design, but it would have been increasingly hard, unpopular. We could have had quitters to get away from the hell of merging, but we moved everyone to a more productive, higher throughput place by installing trunk-based development.
Okay, and now maybe we want to have a look at trunk-based development in a bit more detail. So in your book, you mention a few styles of trunk-based development. Can you tell us what they are?
For sure. There is a historical direct-to-trunk model in the early days of source control in the 90s. Maybe that was the only mode of operation you had, and that you could have a concept of a branch came later, halfway through the 90s. So direct-to-trunk would mean that everyone is going to effectively do their piece of code, hopefully a small piece of code, test it themselves. That would mean bring it up, desk check it on their own machine, run the unit tests as well as every other facet of the build, and then do a commit and a push. Historically, end of the 90s into the 2000s, you might have to stick your hand in the air in the dev room and say, I'm checking in, nobody else check in, and then that ceremony would render this safe. In later years, the source control packages would arbitrate on whether two people could check in concurrently and whether it would still work. Subversion locked that in. Others, like Perforce, had done it some years before. That model really is passé. People don't do that so often, although it's perfectly possible to do in a small enough team who know each other. The second and most popular model, perhaps, is the short-lived feature branches of GitHub Flow. This was a standout feature of GitHub on launch in 2008, and it was a pretty compelling way to work. This one also facilitates surprise pieces of work from outside your team. Many open source teams use this model. The third way of working, in the styles page of the trunk-based development site, is a patch queue. This one also has some historical use. Google implemented their own patch queue, maybe not when they started, but soon after they realized they couldn't get all their developers doing push straight to trunk. And Guido van Rossum had a technology he talked about in 2006 called Mondrian. It maintained pending changes in Postgres, and you could review them in a web application. And if you got enough thumbs up on a particular change, a patch, a change list, you could automate from there its integration back into the trunk. So it would handle effectively everything that GitHub's pull request model does, but without actually using a branch.
How do you choose among these three different styles?
That's a very good question. So if I'm setting up a dev team, I'll probably try and get everyone to push straight back to trunk. Now, I'll get some resistance, but I might be able to carry the day. And this could easily work up to 10 developers who are concurrently committing back to trunk. You could make it higher than that, but you really probably shouldn't. You should shift to short-lived feature branches, the GitHub model. Now, that can scale up to hundreds. And that's why I would maybe make that decision. I have 100 developers. The pull request model is going to work for me. But if I was trying to recreate Google and I'm going beyond 1,000 developers, there's no way on earth that I would choose the pull request model. I'd probably put in one of the patch review systems that exist in open source land.
You said that the second model, so basically using feature branches to work and then a pull request or merge to master. But what is the main difference between this and a branch-based development model? Because, you are still using branches, so where is the difference?
That's a good question as well. So let's say, regardless of the three models that I'm talking about, the team maintains one promise to the bosses, which is, we are always release ready. So say, your CIO, you come in and say, we must release in 1 hour because competitor X has managed to beat us to market on the feature we've all been working on. So in a trunk-based development team, the answer is we are release ready at all moments. Maybe not within a second if we were in thinking we had another 3 weeks to develop. But if we flip some feature flags or toggles, we can maybe stabilize and make a perfect feature representation of what we're doing. But what we had already was the build passes. We could deploy it to an environment. We might already be deploying it to QA or UAT with every commit. But what we have is a capability that long-lived branch teams do not have. We are always release ready.
So you mentioned how long-lived. So I guess the difference here is between the length of time a feature branch is kept open, because you are saying you still have, for something, some branches where there is development and then maybe a pull request model. But I would imagine in this situation, you want this branch to live for a very short amount of time to be called trunk-based development. How long is the life of a short-lived feature branch?
If you ask me, it's a day. If we ask the industry by saying how big is your short-lived feature branch, the typical answers are 2 to 3 days of development and 1 for QA.
And for something that you want to call trunk-based development, how long should it be?
1 day.
1 day.
Max. And that's maybe, your smallest pieces of work are going to be a quarter of a day. It's a bug fix I did, or it's a small feature. I'm 100% confident. I did it test-driven, developed. It went in. It was perfect. I'm picking up the next thing from the backlog, and it's not even lunch yet.
With trunk-based development, how do you manage conflicts when multiple developers are working on the same parts of the code base?
Okay, so first observation is that it kind of disappears. Because these changes are small, the chance that we could actually be working on the same method or function in the same source file in an incompatible way is massively reduced. So anyway, that wasn't answering your question, or at least not all of it. It does happen. And you're going to be pushed into the three-way merge tools of your source control system. And you're going to use three-way merge to arbitrate over our common ancestor, your work and my work. Because these things are smaller, that's still easier to get through. Maybe, you wanted to do a push, you found out somebody else had beaten you to it, so at least to trunk. Your obligation is to pull their changes, go through the three-way merge tool, and then have a second go at pushing your thing back up to the canonical place. Now, it could be that delay on your push of your own work was only half an hour more. If we were in that hellscape of long-lived feature branches, it might be days of merge. It might take multiple eyes and people working in rounds to get the long-lived branch back into trunk or mainline.
And how do you ensure that trunk is always stable and ready for production release? I think we touched upon this a little bit before. So you mentioned some infrastructure testing and continuous integration. So can we expand a bit on this?
Yeah, so your CI tool, Jenkins, classically, is going to pick up your commit or your pull request and is going to run it through a bunch of steps in the pipeline. Compilation, unit tests, 1 or 2 or 3 stages of integration test. Now, in the highest performing teams, it's going to acquire a bunch of ephemeral infrastructure using infrastructure as code scripts to stand up enough of the system to amount to the fullest of tests for the entire change that had just happened.
Some teams use also quite a bit of manual testing for their systems. When you use trunk-based development, is there any space for manual testing? And if yes, what kind of manual testing we can use?
That's a good question, and it depends on your intended release cadence. So a release cadence is how many planned releases do we want to get out in a week, a year, a month? So with that said, if you're intending to do quarterly releases, you have plenty of time for manual testing of an imminent release. If you're intending to do monthly releases, the same is still true. If you're intending to do 1 release a week, then you're maybe stretching what a manual team could do within a week. You need to be maybe code completes 1 or 2 days to go, and then the QA team is going to have a look at the thing. If you move up past daily to 10 releases a day, you've lost the ability to have a manual test as an honest gate of whether we should or shouldn't do the release. So we've probably at some point in that progression lost deliberately our ability to manually veto a release. Now at 100 releases a day, this is GitHub, Etsy, a few others, you're in no place to say no to a release. If you put a bug in production, it'll be resolved through a technique called fix forwards rather than rollback, which is maybe 30 years of well-experienced history of the IT industry.
And let's change gear a little bit. So now many teams nowadays use code reviews before pushing to trunk. What are the best practices for code reviews in trunk-based development?
If you have the code review tool, that would be the short-lived feature branch pull request system of GitHub or the patch queue, which has the review systems built in. The first piece of advice for a trunk team would be to do it as soon as possible after the request has gone out for a code review. Now, Facebook have an interesting story from their past from 10 years ago, where they put a service level in for the DevOps team to have all the automatic data points in within 10 minutes, because 10 minutes was when the early majority of human code reviewers would turn up to review a change within their trunk-based development system. It would be a waste if those people were in the middle of reviewing something only to find out Jenkins 10 minutes later was going to fail that pull request because it was wrong or broke a test or didn't merge perfectly with something else. So they moved it so that the 10-minute average turnaround on human reviews was supported by all the bot data points.
What about teams doing pair programming and mob programming? In those situations, what you would recommend to them?
So I was in Google as a consultant for a period, and not every team, but some teams had an automatic kind of +1 for any piece of code that had been pair programmed. Possible that you still had to have another human weigh in afterwards, but if the two people in that pairing partnership were sufficiently senior on the actual application and with internal qualifications, maybe one was called Java readability. If they were senior enough, that might have been enough to get that thing all the way into the trunk without any other humans reviewing it. So pair programming, for example, is definitely a second pair of eyes. And for some teams, it might be enough, especially for, say, the extreme programming teams of 2001, before Git and GitHub. They would say everything paired, where the developers have been rigorous enough to run all the tests before the check-in and the push. Everything paired would be fine without any further review after that.
So it seems that two dimensions here to keep in mind. One is more than one pair of eyes to look at the code, so a pair or somebody else, but also when it's not a pair or a sufficiently senior pair, as you were mentioning, basically somebody else has to look at the code to decide that it's good enough. It seems that the key parameter there is time. So you mentioned Facebook with 10 minutes, because I would imagine if it takes 2 days, 1 week, or as I've seen in some teams, 1 month to do a review, that cannot really be called trunk-based development by any stretch of imagination.
Absolutely right. You're lying if you're calling it trunk-based development. You're probably a team with a branching model where one of the branches is called trunk, but it's certainly not trunk-based development if you're waiting that long for code to be consumed back into the principally most important place.
And now a different kind of question is around compliance and regulations. There are some people that work in environments where they have to follow some rules for coding because there are some, regulations within the company or maybe within the industry. Have you worked in any environments where there are some specific compliance rules and specific regulations to follow for the code to be accepted? And if so, how did that impact trunk-based development?
So another great question. I think, there's two parts, right? So some of your SOC-style audits concern releases and some of it concerns code in the repo. And you could say that within a source control system that has integrated review, we can actually audit after the event that every single change that went through was appropriately categorized, feature, bug, was linked to a backlog item, a Jira or something else, and that also had a review attached. So maybe if it was a vanilla subversion from the past, you wouldn't be able to do this because it all wasn't done in one technology. But if you're using GitHub or GitLab in this age, you can see all of those things after the event. Now, of course, I think there's still mistakes can be made by a dev team, But as long as you've actually remediated those mistakes before the audit, I think you're okay. So you'd run a script that says, what went into the trunk that didn't get a code review? Okay, we will list those as errors on our part, but we will do the code review now. So it wasn't caught in an audit. It was disclosed to the auditors in a mea culpa moment that we did 18,000 commits, of which 100 were not reviewed at the time, but were reviewed within 5 days of landing in the trunk. So there's many things that a trunk-based development team can do to be audit safe and comply with regulations around those that don't mean you have to slow down. You can keep your full speed as long as you can prove something after the event. Proof is going to be, hopefully, resting on Git and some Python scripts that are reproducible and would please the auditors on at that moment later.
From what you say, it sounds like trunk-based development can be used in environments where there are some strict compliance requirements or strict regulations.
For sure, as long as we're vigilant that mistakes might happen.
Let's change direction a little bit. How do you manage deployment and release cycles in trunk-based development?
That's a good question. You know, it's often the first question I ask to companies I'm consulting with. What is your planned release cycle? Somebody might say quarterly or monthly or weekly. And then I might ask, what is your observed unplanned releases per planned release? Somebody might say every 3 releases we do an unplanned release in the days that follow. And that really drives a lot of questions about what flavor of trunk-based development you're going to do. So not just direct to trunk or the pull request model or the patch queue model, but what are we going to do around CI? What environments do we need? What environments are we going to eliminate? What other parallel techniques might we do? Service virtualization, component testing, contract testing, all sorts of sophisticated things we might want to work into the build. The definition of done, the roles within the team, devs and QAs may be pairing together. The emphasis on or attendance of a backlog, a tracker, the dual attendance of a second system, a trouble ticket system, that could be ServiceNow. It's possible teams can look at 2 queues, planned work and then the surprise work from production. And all of these things drive the general capability and style and experience of releasing and supporting releases for a dev team.
So what kind of models have you seen? Like even with trunk-based development, would you use branching off for a particular release or maybe just put a tag for a release and branch off if you need to do some fixes? How would you proceed with that?
Say you're monthly on your plans, release cadence. You're probably going to cut a release on a release branch on a just-in-time basis, harden that in the hour that follows, lock it, and only cherry-pick changes to it using a responsible member of the team that are bug fixes. You're not going to allow stuff to come up from trunk into the release branch that's more features. You're going to say, wait for your next release, which is a 1 month's time. And if that's not acceptable to the team that's being told, no, they can't merge, then maybe you should have a faster release cadence than monthly. These are the gates that might drive the team's larger experience. You know, make a release branch. The other one you talked about was make a tag. If you've moved from monthly to weekly and then weekly to daily, you might not be making a branch anymore for releases. You might just be making a tag to say we're going to release that. Then a bot picks that up and says that's going all the way into production. If you've moved to 10 releases a day or 100, you're probably not even tagging anymore. The system is making a decision which commits, or commits, plural, will be batched and on what basis. It doesn't really matter anymore. The system is making the decision as to which one's going out, and it's doing the release. And even if it makes a tag, which it may not, the tag is an after the event thing, meaning the release went out and I'm going to tag it, say, that was the 18th release on this date. But at some point they become meaningless too, that if your system is so good that every commit reaches production, there's no point in tagging anymore.
Also, when releasing, many teams use code freezes as well. So can you comment on this? Is there an implication for trunk-based development?
There is. So Laura Wingard and Christopher Seawald did the high-level source control best practices document in 1998. And it talked about branches, and each branch should have a different policy. Code freeze is a policy. So we could apply a freeze to this branch, but not to that one. Now, the reality for trunk-based development teams is they never freeze the trunk, ever. It doesn't matter. You're going at high speed, and if it was you that was making the release branch, you might tell the team, I'm making the release branch in 1 hour, but nobody changes any habits in that time scale. The release branch just gets made without choice, just gets made from head, and then that one is frozen to the developers. You, the person that made the release branch, might be the responsible adult that's going to look after it for the next 3 days before it goes live, but you're going to freeze it and say devs can't commit to it. Devs may request that a commit or commits get cherry-picked to it, which is a specialized form of merge that Git has, Subversion has, Mercurial has. But the freeze of the release branch is because of a policy change, which is devs shall not develop on the release branch. So we said already we don't want additional features rammed in after the branch cut moment, but we are open to bug fixes going in because somebody in the proving cycle for the release that's about to go out that's coupled with that release branch has found a defect. We have fixed that in the trunk. That was unplanned work. We proved that it was fixed. We maybe added a test as well because we're really good test-driven developers. And that individual atomic commit was cherry-picked to the release branch, and none of the intermediate commits that happened after branch cut and before the commit that was eligible for cherry-pick, none of them came with it to the release branch. So we're saying frozen branch, responsible adult bringing stuff to it, matches a defect. We will have to disclose this in a audit cycle maybe. It should have multiple eyes on it, including a manager saying, yes, that should be merged, cherry-picked to the release branch. But that's the only place that trunk-based development allows freezing to happen.
Now, another common issue that I see in teams, that is long-running feature development. So sometimes teams have in their own requirements to develop something that requires time. I've seen that often branches are used for this purpose, like basically feature branches. Yeah, so create a branch for this long-running feature, and we'll work on this for a few weeks, maybe a month, sometimes a few months, and then merge back when we are ready. So if we want to use trunk-based development for these long-running features, what should we do to be able to do that?
We should do branch by abstraction. This is my contribution to the field of computer science. In respect of trunk-based development, I'm just the guy that documents everything. Now, one thing you didn't say was this particular long-running piece of work or long-to-achieve piece of work was probably straddling a number of releases, not just taking a long time in itself. So the answer is that we had something to do in the code base that was large and would take many, many, many commits. What we should probably do is introduce an abstraction for ourselves first that isn't actually anything towards goals, but it facilitates breaking the work up into multiple further commits that don't inconvenience anyone who's working in the same trunk. Everyone else should be able to work at full speed delivering their features. You're doing your feature or your refactoring or your tech debt item, whatever it is that's going to take ages to do, but you're doing it in such a way that no one else in the team notices you're doing it, but you're doing it methodically through 100 commits that might go live in sets of 10 or 15 or 20, but they're all benign in production because they're kind of turned off. Now, the off and on technology is flags and toggles, of which there's many, many ways of achieving that within a code base, using a system to maintain toggles or just having a YAML file in the source tree. But for you as the person who's doing the long to achieve change, you might have the toggle set to new, whatever the toggle name was. Everyone else has it set to old. In fact, that's how it was committed. But you're working towards goals. You're doing commits. They are going live, but nobody else is noticing them. They might notice the abstraction has been introduced, and they have to work with that, but they don't see any of the downside of you taking ages to finish your change. Now, your last piece is you finished the work. There's nothing more to do. You've gone live, so you should probably remove the abstraction. You might even remove the toggle at the exact same moment, or they're done kind of in following commits.
So you mentioned toggles and flags, which are the same things. So can you tell us in practice how they work?
Yeah. It's a software flag that says yes or no, or old or new, or A or B or C or D in some context. Now, that could be something you had on the command line as you start your compiler. So if this was Maven, you could pass a -p profile or a -d flag to the build, and it would go and do something instead of something else. So that would be a build time flag. If it was a more sophisticated tool, then you'd add a parameter to the build, which would be -- with shopping cart, if that was the thing that was being added in your refactoring. That's something that affects the binary from the same set of sources. And if you ran it twice back to back with different toggles, it would make two different binaries without any other changes on your part. And if you've shipped one of those to production, it is that thing, with shopping cart, or another binary without shopping cart. And it can't, in production, be this other thing instantaneously. You'd have to do a rebuild and a redeploy. So the next level along would be, let's ship the binary with shopping cart and without shopping cart logic in it, but it will pick up a YAML file as it boots and say, I have shopping carts, which would give you the option of maybe bringing that service down, editing the YAML, this was not advised, and then relaunching the service in the same infrastructure. Maybe this is before the virtualized era, and it would suddenly have shopping cart in production when it didn't have shopping cart a few minutes before. So that's a toggle that would be shipped with the binary that is all things to all people, but shapes the behavior of the binary in its environment. The third kind of way is to have a toggle system. So this would be a server on some basis that has shopping cart or does not have shopping cart. And the application as it launches would phone home to the service and say, should I show the shopping cart or should I hide the shopping cart? And that would be able to disseminate toggle states to running services and applications, such that maybe in the middle of the day, and not having to reboot the stack at all, you could change the flag from does not have shopping cart to has shopping cart, and all of a sudden the system would show that to the next user that visits the page in question where the shopping cart could, or in alternate configurations, may not be. So that's really, in my view, three broad categories of flags and toggles. Ones that work at build time, ones that work at boot time, and ones that don't require any reboot or deployment of the software at all, will just work based on whatever an operations team does in a page that says on or off or yes or no.
So are there implications in trunk-based development for the team itself? Like if a team has specialists, say somebody that only does UI, somebody else that only does backend development, somebody else that is just database, is this a potential problem for trunk-based development?
If they refuse to slowly learn the other technologies, yes. So what we really want is T-shaped people. So you're a bit deep on one thing, like I'm really good at CSS, but I will get on, less excellent, but still adept with the full range of technologies that I need to use within the dev team. So you want a team of multiple T-shaped people where every specialization is covered by someone who is a specialist, but that gradually all the skills move around the team, regardless of hopes for individuals within the team.
If I'm understanding correctly, what you're saying is if we have a team where a team and perhaps a company where the culture is of high specialization of what people do, using trunk-based development may become difficult in that context. Am I correct?
If they refuse to become polyskilled, every team would start where you're describing and then jump into the opportunity to train up colleagues in the same skills that they're very good at. Not to the same level, but at least no longer beginner on those technologies.
So your experience is that this is actually not a real problem in practice.
If you've achieved trunk-based development, you probably have started to solve this one problem.
Let's talk about the role of tools. Are there any limitations in the tools that we need to be aware of when we want to use trunk-based development?
Yeah, so historically, not all the tools would be equal on their ability to do three-way merge, but I think that's been leveled up. If we talk about Git in particular, you have to do a pull before you do a push. If somebody else pushed before you to the same branch, you won't be able to push. You'll have to do a pull first. Now, this was for the longest time of Git's life a problem. In the last year or so, a number of strategies and capabilities in Git as a tool have evolved to actually almost eliminate this problem. But let's go and say what the worst incarnation of the problem would be. You're in a large team, 100 devs. Everyone does 4 commits a day that they push all the way back to trunk. You might finish a piece of work and then do commits. It works for you because you're distributed. Then you might do push, which is to get all of your commits back to origin. But it says you can't do it. So you go, oh, somebody else worked. I do a git pull, merge conflicts, or I've got to run the build again because I'm a good citizen. Then you do a push again and you find out somebody else baited you to it as well. So the problem is that you might be in that push-pull bottleneck forever if the team is huge and has a high throughput, commits back to the trunk. So you might regret your decision to use Git for that. But my observation is this problem has started to be eliminated by strategies for merging, or merging back to origin, fast forwards and the like. And it's less of a problem than it was 5 years ago, and roll forward 5 years more, and this might be absolutely invisible as a problem.
About other tools now, do IDEs have a role to play as well?
These days, the IDE has to understand the source control technology natively. It's not just shelling out to the command, git, subversion, mercurial. This is actually having the features built in so that it can represent change, divergence. It can arbitrate, maybe even be, on the low end, an admirable tool for merging three ways. But, the answer to your question that you put is we do need tight integration with the source control package in the modern age. And we would not use a source control package that didn't have tight integration.
In your book, you talk about the importance of a local build.
Yeah.
So can you expand on that?
So this has been the tradition for the continuous integration teams, the test-driven development teams, the extreme programming teams. And we just have to continue it. So you can't really say you're high throughput unless the change you're pushing back to trunk passes all of the same tests that the CI bot would do as well. And you don't want to duplicate that. So that means that basically the same technologies that you would use to certify that something passes all checks should be doable on your dev workstation in your checkout. Before commit, after commit, it doesn't matter. It must run on your Mac or your Dell or your ThinkPad.
Okay, so the importance of the local build is basically to give developers that are going to push something to trunk a high confidence that the thing is going to work. So I guess, and a lesser chance of having problems when breaking the build or maybe clashes with other merges. And let's now talk about something else that is about actually implementing trunk-based development. So let's say an organization has decided to go towards trunk-based development. So are there any situations in which you would recommend the organization not to do that?
Well, if you don't have any tests at all, any automated tests, you'll be in a pickle. But that doesn't mean to say you can't take it on at the same time. Other pitfalls. What's your current cadence into production for planned releases? Maybe don't shoot for the moon and say we're going straight to CD, which is a flavor of trunk-based development. And there are two CDs. There's continuous deployment and continuous delivery. But don't do either if you've got no tests. Don't do either if you are starting from a point of quarterly releases. Choose a way of working with trunk-based development that matches your current cadence. Then just experience trunk-based development in that design. Then think about dialing up from quarterly to monthly or monthly to weekly. That's on the planned releases. Try and worry about your unplanned releases, which are the bug fix ones. You want to eliminate them if you can. Choose any strategy to do so, but the most solid one is have more automated tests. Make it an obligation that the devs who do work write the tests, at least the unit tests. QAs have skills devs don't. QAs, for one, know what not to test. But they should be in the dev team too, and they should be committing and not be manual. They should be learning the same technologies, be that TypeScript or Java. They should be crafting their skills with frameworks, NUnit, JUnit, Cucumber, Selenium, Cypress. And everyone should be living in this world where the work we do is in small batches and it goes back frequently and none of it breaks the build. All of it increases the solidity of everything, meaning all tests pass. Hopefully they're fast. There's other things we can apply to make them faster without running all of them. But we do that slow ratcheting forwards from the place we first arrived at as we quested for trunk-based development, say a matched set of ways of working that matched our quarterly release cycle. We experienced that and then dialed up the release cadence slowly after that.
Are there any particular strategies that you would suggest for implementing trunk-based development in, say, greenfield projects or brownfield or legacy ones?
I think we covered legacy, let's recap. Be careful. Choose a way of working that doesn't upset everything around your cadences, your batching of work, your work streams, your prioritization. But if we talk about startups, there's no employees yet. It's you as CTO, and you're going to do all the hiring and you're going to align people. You should start with trunk-based development, and you should never lose it. And this was this is Google's big advance in. They didn't quite start in, say, 96 with trunk-based development, but by 98 when they put in Perforce, they had super achieved on this thing and they never lost it. Now, you start as you mean to carry on. You hire people. If they've never done it before, you'll train them. How do we do the batching of work? How do we do the tests? Here's your first pairing opportunity. Wasn't that fun. Look, this is a build breakage. Let's do our blameless autopsy. But we're not live yet, so we've got some run-up. So we craft our skills with trunk-based development. If we think about maybe a startup as well and think there's front ends and there's back ends and then there's related non-real-time services.
We said that for greenfield project, you said that you would recommend trunk-based development every single time. But for brownfield and legacy ones, they would be using maybe Git flow or some other branch-based, possibly in-house custom way of branch-based process. And they may also have lots of manual testing, not a lot of automated testing. So how can these legacy or brownfield projects, what can they do to move into a trunk-based development process, but in an incremental way?
Yeah, there's some readiness things, right? We have to speak to the QA group and talk about shifting everyone from manual to automation skills. If we're a generous company, generous brownfield, we'll train in working hours using courses, Pluralsight, and others on some of that stuff. We'd give support as people are learning this craft. That feels to be a long thing to do. It'll take 6 months to take somebody from manual to some level of confidence with, I can commit, I don't break the builds, I see the new techniques. But the other aspect was short term. Let's say we're planning this from other branching model, long-lived, to trunk-based development, and we're counting down to like a cutover moment. If we try this big bang, like moving 5-8 teams from other branching model to trunk-based, we could have egg on our face, regret. We could cancel it or abandon it after a week, be forced back to the old place, and now with the additional bitterness of the business because we had downtime in that time. So a better plan would be to phase an implementation. And I did this in Chicago. It was a bank. They were in ClearCase and another branching model, quarterly releases or maybe one release every 4 months. And we planned between 2 releases to migrate everyone, ultimately 200 contributors, from the other branching model in ClearCase to back then trunk-based development in a monorepo, trunk-based development in Perforce. And what we did was we sequenced the teams in order. We'll move you on Monday. We're going to hot train everything in front of you. You have a day of downtime or half a day. We'll show you some stuff. We'll add some tests that make things more solid at the same time. But by Wednesday, we should be done with you and have moved to a new team, another team on another module within the same larger application. It was a trading application. And, if you have enough time between releases, you can do this migration. It's a little bit military, but you've got time to complete a migration of all the teams from the old place to the new place, from the old techniques to the new techniques, if there's some top-down encouragement and some bottom-up support for the same. And you also have time, really importantly, to deliver all of the functional commitments you'd made for the same release cadence. Let's say in this case, it was 4 months. So as long as we've achieved all of the functional deliverables that the team previously committed to or regularly did within that interval, and we did all this housekeeping stuff, which was shift to trunk-based development, then we can be left in a good place. But if your migration plan included downtime that was significant and multi-person before you'd be in the new place of trunk-based development, in that case for the bank, monorepo 2, if you have the downtime and there's observation of that downtime from management, business management, there's the possibility that somebody at some point can't withhold their better judgment any longer and is going to blow a whistle and say, get back to work, which then means go back to the functional deliverables only and do none of this housekeeping stuff, meaning you're forced back to the other branching model. You didn't delete it. It was always there. You just went back to that repo and you carried on, or that branch. And nobody in the same organization is ever going to be able to suggest trunk-based development or any of the related practices or monorepo again. Maybe careers changed also as part of this whistleblowing activity. So in summary, choose a methodical way of getting from your place in brownfield land to your better place in baby steps that is concurrently delivered with functional commitments. That way you can kind of avoid the everyone stop fear that some of us have been veterans for years, have experienced many cancelled projects and only cancelled because we were late. So through a methodical approach and a dual track, we will do functional deliverables at the same time. You can possibly get to your place. And as we did for this bank, this material made it into the continuous delivery book, by the way. As we did for this bank, I think we went live 2 weeks early on the 4-month plan. And the business thought we were geniuses, which we weren't. And, wanted to know if we could do it again for the next release. So, we were a bit lucky, I guess, in retrospect, but we achieved all the functional deliverables and the big migration to a better way of working for development, all within the committed release cadence.
Which brings us to a follow-up. That is, changing this model is a big thing in a company. I mean, a company that relies on software because maybe what implements a service they sell or is a product they sell to their customers. Obviously, the way software is produced is important. So what happens if you don't have support from the top to go into trunk-based development? So if you have the teams that say, look, we really want to do trunk-based development here, we think it will give us advantages, but management is not convinced.
Yeah, without top-down support, your bottom-up crew of, let's say, senior techies that say, we must do this, we did it in the last company and the one before that, they're not going to prevail. You have to convince management. Same time, you can't have management figures, you or me in the CTO roles, saying we should shift to this trunk-based development when none of the practitioners support it as well. So you need top-down and bottom-up support, or you probably shouldn't do it. Meaning every time I've seen one without the other, it's always been cancelled or flaccidly attended and then, no benefits a year later, despite all of the meetings we had about it. So you need the support before you do it. And that includes management and that includes business management, not just IT management.
So one of the preconditions to move to trunk-based development is actually commitment from all stakeholders in the company.
Yes.
To it.
Now, you could do that through, we're going to talk about this change. We're going to sell it. We'll do an offsite. All the management figures are here. We'll explain the other companies that have done it, the productivity benefits afterwards that don't mean people are working twice as hard. And then you've convinced some of the people in the room. Another group in the same room might just withhold or suspend their better judgment. Hopefully they become convinced in the fullness of time because you made zero mistakes against this promise. Certainly in the airline, people that were against the trunk-based development move thought, for the longest time, they'd go back to their branching model when, say, ThoughtWorks had left. But when this reorganization or resequencing moment came a couple of years later, they were total converts to the idea of trunk-based development and branch abstraction and feature flags toggles, because it eliminated an entire round of recrimination around a botched release and a zero productivity moment as we unpicked merges. So, they withheld judgment and later became converts because of an economics thing, which was, I think I did a speech and I called it hedging, but really it's options on the orders of release. And they saw it from an economics point of view when Paul, the passionate techie, only sees it from a Paul, passionate techie point of view.
So you just mentioned economics. That was something that convinced people that was the right thing to do. So is this a way you measure the success of trunk-based development? So when a company says, okay, we'll go from what we are doing now, we'll go to trunk-based development. But then is how can we measure that the move to trunk-based development is actually something that is better than what we were doing before?
Because you're moving faster than your competitors now that you have this, I'm going to say military, you have this military organized dev force. I used to do a keynote, for not the big stage, but at corporate developer conferences. The decision that Google made to put in Perforce and choose trunk-based development, which was Craig Silverstein's decision, he was the first hire, was 1998. Perforce also went into Microsoft, although they called it Source Depot. And the Perforce sales folks said you can choose any branching model you like, and Microsoft listened to that and made lots and lots of branches, like ultimately thousands within the Windows repository. And Microsoft has done blog entries about how they've remediated that and finally gone to trunk-based development, say 2014, 2015, that sort of time frame. But in all the intervening years, Google was doing trunk-based development in a monorepo, was adding tooling to take away human things that could be automated, add data points, make it frighteningly hard to meet standards to get a commit in. And Google had significant competitive advantage on the productivity per developer from 1998 through to the middle 2010s. I think Microsoft's closed the gap in a number of their assets, Office, Windows, some of their mobile things. But Google used this economic advantage to totally dominate Microsoft on at least the topic of mobile phones, Android in particular. Before Android came along, iOS was maybe a year old, but the second technology was Pocket PC or Windows CE from Microsoft, and it just disappeared. Microsoft, using their ways of working and their multi-branch model, couldn't compete with Google's way of working, trunk-based development, albeit substantially in Git, not Perforce for the Android team. And there was a mismatch on this competition towards dominance of the second mobile platform after Apple.
So in short, what you're saying is that actually using trunk-based development increases, if you like, the flow of features developed over time.
Yeah, but fast pivoting too.
And fast pivoting too. So even changes of direction can be, for whatever reason the product needs to change direction, can be actually implemented much more quickly.
Yeah. One of my old bosses was Jay Bloom, big speaker on the Lean Tour. And he said, think about it, the fastest moving, highest pivoting organizations are great. But if we shift to, say, Formula One or NASCAR, and there's the person who's at the front of the entire pack has somebody that's threatening them from behind, they spend more time looking in their rearview mirror, and actually the lap times go down as they're trying to stop the other person passing them. So if you have a competitor that's close to you, you malperform even when you're in front. The other person doesn't have enough width on a Formula One track to overtake anywhere, but if those tracks were much wider with less turns, the person who's approaching you from behind would get past you every time. So your tactics change as an organization. And Jay was pointing out, this metaphor of the person in front is looking in the mirror. What you would hope as an organization is there's no one to look in the mirror to. What you should do is everything you can to make sure that you're so far ahead of your competitors that they never get close to you. But what a complacent, slow developing, non-trunking team is doing is driving at the front because they were first mover, but they're moving slowly. And the competitors are going to streak past you, not just one, but maybe multiple. There was a case where Travelocity, a travel booking portal of the US, was an award winner of 95, 96, 97, 98. And then Expedia went past them on that leaderboard, and a few others did too. You can't simply be first mover and keep that position. You have to continue to innovate in your engineering workforce. And that doesn't mean offshore it. That means get better at practice, get better at batch sizes, get better at quality, automate some things away, add a whole bunch of other things you were never doing before in order to make better and faster.
And trunk-based development, from what you say, seems to be one of the important tools to actually being able to do that.
Yeah, it's always there.
I think we've done a great job of introducing trunk-based development. But if there was only one thing that you would like a listener to remember from this show, the most important one, if there is one, which one would it be?
Commit little and often, and don't break the builds.
Commit little and often and don't break the build. I like that one. I'll use that one myself. Okay, thank you very much, Paul, for coming to the show. It's been a real pleasure. And this is Giovanni Asproni for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.